Imagine this for a moment. The universe is not empty because no one is out there, but because the universe itself has decided no one should ever meet. Science fiction trained us to dream about a galactic club, a place where advanced civilizations trade knowledge across the stars like neighbors swapping stories. But when we stop dreaming and start measuring reality through physics, that fantasy collapses fast. When we examine the cosmos through the lens of higher dimensional theory and hard data, a colder picture emerges. We may not be alone by accident. We may be isolated by design, quarantined by the very laws that hold the universe together. Space is not just big. It is weaponized by distance, time, and energy in ways that no civilization, no matter how intelligent, can casually overcome. To understand this, we need to start with scale, not opinion, not hope, just numbers. Even on the Kaku scale of technological advancement, a young Type 1 civilization like ours is effectively trapped in a cosmic desert. Our closest stellar neighbor, Proxima Centauri, is only 4.24 light-years away, which sounds nearby until you convert that distance into reality. The fastest object humanity has ever built, the Parker Solar Probe, reached roughly 430,000 miles per hour. At that speed, reaching Proxima Centauri would take more than 6,000 years. That's longer than all recorded human history, just to arrive at the nearest front door in the galaxy. This isn't a problem of ambition, it's a wall built from distance alone. Our region of the Milky Way is not a crowded city, it's a scattering of tiny islands, each star separated by an average of 5 light-years of darkness. Light, the fastest signal the universe allows, takes years to cross these gaps. That alone ensures that interstellar contact is not just difficult, but functionally impossible for any species bound by known physics. And distance is only the first barrier. The second is absolute. In 1905, Albert Einstein formalized special relativity, establishing that the speed of light, exactly 299,792,458 meters per second, is not a guideline. It is a hard limit written into spacetime itself. As any object with mass accelerates toward that limit, its effective mass increases, and the energy required to push it further rises exponentially. Reaching the speed of light would require infinite energy, something that simply does not exist in a finite universe. This alone dismantles the idea that advanced intelligence can simply go faster. Popular loopholes, like warp drives and wormholes, don't rescue us either. Mathematical models such as the Alcubierre drive suggest spacetime could be warped, contracting space in front of a ship and expanding it behind. But simulations show this would require negative mass or exotic energy densities that we have never observed in stable form. Holding open even a microscopic wormhole would demand energy comparable to the mass of entire planets. Trying to stabilize such a structure using quantum effects would be like attempting to hold up a collapsing skyscraper with a single feather. The mismatch is absolute. Even if we abandon fantasy solutions and assume something more modest, say a ship capable of traveling at 10% of the speed of light, the numbers remain brutal. Accelerating a relatively small spacecraft of about 1,000 tons to that speed would require energy equivalent to detonating 150,000 nuclear weapons. That's more energy than the entire nuclear arsenal of Earth combined, expended just to start the journey. And acceleration is only the beginning. At relativistic speeds, space itself turns hostile. The interstellar medium is not empty. It's filled with hydrogen atoms and dust grains drifting invisibly through the void. At 10% of light speed, a single hydrogen atom strikes with the kinetic energy of a high-speed bullet. A spacecraft wouldn't be flying through space. It would be enduring a constant sandblasting from trillions of microscopic projectiles every second. Without meters of dense shielding, the hull would erode rapidly. But adding shielding increases mass, which increases fuel requirements, which increases mass again. This feedback loop is known as the tyranny of the rocket equation, and it locks civilizations into their home systems with mathematical cruelty. From a quantum perspective, the universe doesn't resemble a social network. It resembles an archipelago of isolated awareness. Distance alone isn't the problem anymore. Time becomes the next executioner. Even communication collapses under its weight. If we send a simple radio signal to a civilization 1,000 light-years away, a basic greeting, the response would take another 1,000 years to return. By the time a reply arrived, the civilization that sent the original message might no longer exist. Entire cultures could rise and fall between syllables. This turns every attempt at contact into a gamble against extinction. We are not conversing across space. We are shouting into a canyon so vast that the echo returns after the speaker is gone. The laws of physics act as quarantine officers, not by force, but by inevitability. They allow us to observe the universe, but forbid us from touching it. The music of the spheres may be playing, but each instrument is sealed inside its own soundproof room. Even if a civilization somehow survives the engineering nightmare and reaches near-light speed, another barrier appears. Time dilation. At 99.9% of light speed, a 10-year journey for the crew corresponds to more than 2 centuries passing back home. Any return would be a return to a civilization that has forgotten them, evolved beyond them, or vanished entirely. Interstellar travel becomes a one-way trip into the future, severing continuity with the society that launched it. This single fact destroys the idea of interstellar empires. Even a Type II civilization, one capable of harvesting the full energy output of a star, could not maintain meaningful cohesion across light-year distances. Colonies would drift apart culturally and biologically, separated by centuries of delay. They wouldn't form a unified species. They would become isolated branches, each evolving alone. Then there is the issue of detection. Moving large masses at relativistic speeds generates gravitational disturbances. If advanced civilizations were routinely accelerating or decelerating starships near Earth, our instruments would notice. Observatories like LIGO and Virgo are exquisitely sensitive. Yet they detect nothing beyond natural cosmic events. No signatures of interstellar traffic, no evidence of neighbors slamming on the brakes nearby. This silence is not mysterious when viewed through physics. It is exactly what the equations predict. The firewall is holding. The galaxy is not empty. It is inaccessible. This perspective reframes the Fermi paradox entirely. The question isn't, where is everybody? It's, how could anyone ever get here? Data simulations of galactic evolution suggest civilizations may bloom briefly, perhaps lasting 100,000 years or less. In cosmic terms, that is a blink. Against the universe's 13.8 billion year timeline, the odds of 2 civilizations existing at the same time, within reachable distance, are vanishingly small. They don't need to be rare. They just need to be separated by time. Picture 2 ships passing in the night, except the night lasts billions of years, and the ships are oceans apart. The universe is not structured for rendezvous. It is structured for isolation. Fundamental constants like the Planck length and the fine structure constant are tuned so matter remains stable, but large-scale movement remains restricted. If gravity were weaker or light faster, the stars might be accessible. But in this universe, under these rules, they are not. We can see this reality unfolding in real time. Probes like Voyager 1 are drifting into interstellar space, silent ambassadors of our ambition. They will wander for tens of thousands of years before approaching another stellar region. Long before that, their power sources will die, their messages will erode, and the civilization that built them may exist only as a geological trace. This is the relativistic firewall at its most unforgiving. It doesn't merely stop us from traveling, it prevents us from mattering beyond our local neighborhood. Even if life is widespread, every instance may be locked into its own bubble of spacetime, unable to interact meaningfully with any other. From a string theory perspective, every particle is a vibration on a fundamental filament. Moving those vibrations across higher dimensional bulk space requires energy that leaves gravitational fingerprints. The absence of such fingerprints suggests that no one is crossing those boundaries nearby. The symphony exists, but the musicians are forever out of sync. This isolation isn't philosophical, it's mathematical, and it becomes even more severe when we account for cosmic expansion. Dark energy, the mysterious force driving the expansion of the universe, acts like a cosmic warden. It stretches space itself, increasing the distance between galaxy clusters faster over time. Roughly 68% of the universe's total energy content is devoted to this expansion. Every second, regions beyond our local group slip further away. Eventually, they will cross a cosmic horizon beyond which no signal, no matter how powerful, can ever reach them. This means we are living in a brief golden age of astronomy. In the distant future, the night sky will grow dark as light from other galaxies, redshifts beyond visibility. Future astronomers will see an empty universe and may never know it was once full of galaxies. Even a hypothetical Type 3 civilization would face this limit. Expansion itself outruns light. Some physicists take this further, proposing that our three-dimensional reality may be a projection of information on a distant two-dimensional boundary. If that's true, then limits like the speed of light may be rendering constraints, similar to how a video game limits draw distance to preserve stability. The universe may enforce a maximum contact radius to protect causality. This leads to the temporal isolation hypothesis. Civilizations are not just separated by space, but by timing. Habitability windows are narrow. Technological phases may last only thousands of years before collapse or transformation. For two civilizations to overlap spatially and temporally is statistically negligible. We observe exoplanets in habitable zones, but we see them in the past. Their present state is unknowable. We are surrounded by ghosts, not neighbors. When we accept this framework fully, the loneliness of the universe stops being a mystery and becomes a design feature. The final wall separating civilizations is not distance, speed, or even energy. It is time itself, stretched thin by cosmic expansion and locked into a one-way flow that refuses to wait for anyone. The universe does not pause to allow coordination. It moves forward, indifferent to whether intelligence manages to synchronize across its vast scales. The expansion driven by dark energy ensures that this isolation only grows stronger. Every second, distant galaxies are pushed farther away, their light redshifted beyond detectability, their information lost to us forever. We are living in a narrow window of cosmic history where the universe is still visible, still connected enough for us to observe its structure. In the deep future, even this privilege disappears. The night sky will fade into darkness as every external reference slips beyond the horizon of causality. The universe will not look empty because it is empty, but because it has become unreachable. This places our era in a rare and fragile position. We are early enough to see the cosmos, but late enough to understand it. That combination may never occur again. Any civilization arising trillions of years from now may see only its own galaxy, unaware that anything else ever existed. From their perspective, the universe will appear static, small, and silent. Our current awareness is not the norm, it is an exception. The implication is stark. If intelligent life is common, it is still functionally invisible, not hidden by intent, but separated by the uncompromising geometry of spacetime. Every civilization becomes a closed system, bounded by horizons it cannot cross. There is no shared destiny among stars, no collective evolution of intelligence across the galaxy. Each world must confront the same questions alone, develop technology alone, and face extinction alone. This reality dissolves the expectation of discovery. There is no final reveal waiting for us beyond the next star. No ancient network humming quietly in the background. The silence is not temporary, it is structural. The universe is not hostile to life, but it is profoundly uninterested in facilitating connection between lives that arise within it. And yet, this isolation carries an unexpected weight of meaning. If consciousness is rare, not because it is unlikely, but because it is isolated, then every instance of it matters more. There is no redundancy at a cosmic scale, no backup copies stored across the galaxy. What happens here matters because it only happens here. Our culture, our knowledge, our mistakes, and our progress are not being mirrored elsewhere in any coordinated way. The absence of a galactic audience does not diminish us, it centers us. It forces the realization that responsibility cannot be outsourced to a higher intelligence or delayed until contact arrives. There is no outside authority, no cosmic parent civilization, just a single species on a small planet inside a vast system that will not intervene. In this light, the idea of cosmic quarantine is not purely bleak, it is stabilizing. A universe where civilizations cannot easily reach one another may be a universe that avoids endless conflict. Isolation becomes a form of containment, allowing intelligence to evolve without being immediately erased by something older, larger, or more aggressive. The same laws that prevent contact may also preserve diversity by preventing domination. What remains, then, is choice, not about whether we will meet others, but about what we do with the time and space we are guaranteed. The laws of physics have drawn the borders. Within them, everything is still undecided. We can turn inward, fragment, and fade, or we can recognize that this isolated island of consciousness is rare enough to protect. The universe may be vast, ancient, and fundamentally lonely, but it has given us one extraordinary gift: time to understand our situation before it closes the door completely. What we choose to do with that understanding will define not just our future, but the only future we will ever know. If this perspective changed the way you think about our place in the cosmos, take a moment to like the video, subscribe for deeper explorations like this, and share it with someone who still believes the universe is waiting to answer back.